Hi, welcome back to Mrs. O'Graham's Maths. Today we are going to look at continuity and then differentiability after that one. So continuity means we're looking at whether a graph is continuous or discontinuous. That's exactly what you might naturally expect it to be. Continuous means that the function carries on through the whole graph without any breaks in it, and discontinuous would have some breaks in it. So something like this. So we might have possibly a quadratic, or you might have a cubic, or you might have a graph that's doing all sorts of things as long as there's no break in it. All of these are continuous. So all of these are continuous and they can be drawn without lifting your pen off of the paper. But a discontinuous graph might have some, well, it will have some breaks in it. So it could be something like this, if we go for the simplest one, where you have a hole in it represented by an empty circle at that point. So that one would be discontinuous, although the function kind of lying underneath that gap would be a continuous one. Because we've got that gap, it's counted as discontinuous. Or it could have an even more obvious break in it, maybe something like this. It does something up to one point and then it starts at another point and starts doing something else. So both of those functions would be discontinuous. So here we have three functions to decide if they are continuous or not. This does also link in a little bit to the limits in the last video if you want to go look that up on the playlist. So let's start with A. So is A continuous or not? Well, we have this nice straight line going on, but right here we have a gap in it. So A is going to be discontinuous. Then B is a modulus graph, so we have something a little odd going on here at the 0, but it doesn't stop. It doesn't have any gaps in it or any changes other than it just changes direction. So that one will be continuous. And then finally C, we can see we've got an asymptote going on here. Through x equals 1, we've got an asymptote breaking up the graph there. So there is a change in the two portions of the graph, a gap between them, so that one will be discontinuous. Now from there, this leads us into differentiability. Now, if a graph is not continuous at a point, we can't differentiate it at that point. So that's the first thing to think about. But also, not every graph that's continuous is differentiable. So if it's possible to find the derivative, then we call it differentiable at that point. That means it must also be possible to draw a non-vertical tangent at that point. So when you're looking at this on graphs, that's a way to think about it. Now that won't be possible to do if your graph has any sharp turns in it and making corners. You won't be able to draw that tangent that you're looking for, so you wouldn't be able to differentiate it and it wouldn't be differentiable at that point. All right, so let's take a look at this example graph, and we are being asked to give the x values for when this function is not continuous and also when it's not differentiable. So not continuous, we're looking for breaks in the graph, and we have that happen just here, which would be on our x-axis at -1. So we have x equals -1, and then the next break that we get in the graph is just here, where x would be 4. So our graph is not continuous at x equals -1 and 4. Now for the next bit where it's not differentiable, we can first of all straight away write down the values of -1 and 4, because if it's not continuous, it's also not differentiable. But there is also another point where it's not differentiable, where we have a bit of a corner in our graph that where we haven't picked up that it's not continuous, because it is continuous, but it's still not differentiable. And that's up here on this peak of that bit there, where our straight line turns into a curve. We have something else going on. So the other point that is also not differentiable is at x equals 2. And there you have the basics of differentiability and continuity. Good luck with your studies. Hope you found this video useful. If you did, click like and subscribe, because it'll help other people come across it too and give them a hand. Thanks. Bye.